Okay, more on section 1.4 and a bunch of definitions. Here we want to look at boundedness or bounded sets, and then also the idea of connected or separated. Okay, that kind of thing. All right, so bounded. G is bounded if G is a subset of some open disk. So this is our subset symbol here. Some open disk centered at the origin. So if that's for some R. Okay, so for instance, in the complex plane, if I have a set there, then certainly if I go up here and figure out how tall this is or if I get the maximum modulus of anything in this set, and I just make sure I pick an R that's bigger than that modulus, then here's R, then G was bounded. Okay, but it would be, if, suppose I simply took what we think of as the y equal x line, okay, but just sent it that way and that way, then never could I actually get that disk to hold everything, right? So this y equals x line is unbounded. Okay, because I can't put it in the disk. Now, there are actually cases of infinitely long paths, though. So you might say, well, suppose, I can think of this. We'll talk about paths in a minute, but I can think of this path here and say, well, oh yeah, it's an infinitely long path. So of course it's unbounded. Well, not necessarily, because there are paths. You can describe paths that say spiral like this, but the spirals get closer and closer together and so forth, and they never get outside a certain circle. Okay, so for instance, if you let x equal something involving cosine of t, and y something involving sine of t. Okay, now what I could do is I could let t go to infinity, right? But I'm going to do it in such a way that I'm going to bound this whole thing by 1. And so suppose here I do t squared plus 1, t squared plus 1. So I'm never dividing by 0. And then on the top, I just put t squared. So you see, this will be a spiral similar to what we have right here, because the x is, for any given t. So suppose t equals pi over, suppose t equals 0, right? At t equals 0, I'm at 0 because t equals 0. But then when I get to pi over 4, well, that's 45 degrees, but the length here is pi over 4 squared divided by pi over 4 squared plus 1. So I'm going to be, out here somewhere near a distance of 1 in x and y. So, I'll be less than the square root of 2, though. So if this is d0 square root of 2, when I do these points, when I get to pi, I'll get to pi squared over pi squared plus 1. That'll be pretty darn close to 1, but not quite there. And so, well, actually that it won't be a beautiful spiral in some ways. That'll be a little shorter here. So this will be kind of a wobbly shaped thing. I'm not sure why this has gotten less bright all of a sudden, but I don't know if it looks less bright to you in the screen capture or not, but it does to me. So anyway, though, so here is an infinitely long path that I can describe, but it's still a bounded set in the complex numbers. Okay, so it can be bounded that way. All right, then more definitions. Two sets, x and y, subsets of the complex numbers, are separated if there are disjoint sets, open sets, A and B, in complex numbers, such that X is a subset of A and Y is a subset of B. Okay, so what that's saying is, I can draw, some open set here that I'll call A, and some open set there that I'll call B, and then X and Y have to be somewhere in here. Now, they may be closed, they may be open, they may be neither, but the idea is that they're at least separated by a point. Now, they could share a boundary, right? So actually, the two sets A and B that I just drew here, if I drew them well enough, are separated, right? Because the idea is this notion of disjoint. Disjoint means they don't share any points in common. So actually, basically what you're saying is that I'm going to call X and Y separated if I can find a couple of open sets A and B that are separated that happen to contain X and Y respectively. Okay, seems reasonable. Okay, so that is the idea of being separated. Now, connected. Okay, so a single set, set G, subset of complex numbers, is connected if it is impossible. Okay, so there's no such path or no such way. I was going to say path, but well, we haven't talked about path yet. But if it is impossible to find two separated non-empty non-empty sets whose union is G. Okay, so you can't break G up such into two separate sets such that those sets would be separated. Just can't happen. Okay, and then finally, a region is a connected open set. Okay, so for instance, DAR is a region. Okay, so we'll call that good for these.